Hi, hello everyone. Welcome to today's webinar. Sorry about this delay. There was a slight technical glitch in getting the logins from access. Hope we're all sorted for now. And perfect. Oops, I'm sharing the right screen. No. Can everyone see my screen? Yep. Okay, perfect. Hi, Kia ora. Welcome to today's webinar. It's the award winners presentation. And I'm your host, come moderator. My name's Dhanush, and I'm speaking to you from Auckland, New Zealand. Before we begin, let me do the acknowledgement of the country. In the spirit of reconciliation, the ITE ANZ acknowledges the traditional custodians of the country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders, past, present, and extend that respect to all Aboriginal and Torres Strait Islanders people today. We acknowledge and respect the Treaty of Waitangi and Maori as the original people of Aotearoa, New Zealand. So before we begin, a little bit on about ITE. So we're an international association of transport professionals working towards a common goal of mobility and safety for all transport system users. We're about in 75 countries and more than around 70,000 members. And we're always welcoming new members. So please log in and have a look if you're not a member. Thanks for subscribing anyway. Before we proceed, none of our events and this webinar would have been possible without our sponsors. So we thank Austraffic, our platinum sponsor, for the worldwide leading opportunities. Traffic Works for our undergraduate student awards. Cedro Solutions for the President's Dinner and Postgraduate Award. O'Brien Traffic for the annual breakfast meeting and the corporate supporter. Lindsay Oxlade Consulting for the Young Professional and Emerging Leaders Award. Movement Place Consulting and Traffics Group to support the Monash student chapters. We have three presenters today. Sakita Kumarage, who's a senior consultant in KPMG. Isaac Mann, who's a PhD candidate in the University of New South Sydney. And Max McCardle, who's a senior engineer in Safe System Solutions Private Limited. Before we begin, a bit of housekeeping. All the attendees will be automatically muted. If you have any technical problems, which we had already in the past, so please reach out in the chat. Q&A will be after the presentation, and please enter the questions in the Q&A and not the chat. Thank you so much. And with that, I would hand over to Sakita, who's the 2023 Cedro Solutions Postgraduate Award winner. Sakita, up to you. You can share this. I'll stop sharing and you can share.
Yep, thank you, Danish. Hi, everyone. My name is Sakita, and I'm a senior consultant at KPMG. Today, I'm going to present you on my PhD work that I did sometime before last year. Right. Can you see my screen?
Not in the presenters mode. We could see your presentation.
All right. I think it's correct now. So today I'm going to talk about one of the components of my PhD, where my PhD is mainly focused on demand estimation for large-scale traffic networks. And in this PhD, I focused on one component for today's presentation, which is the state and demand and state estimation for perimeter controls in large-scale urban networks, which I will go detail soon. So this is a combined work of myself, my supervisors, Dr. Mehmet Yildirim, and Professor Zudo Zeng. So we are talking about controlling traffic in a large-scale traffic network. So let's say, as I shown in this um, video, which is a large network of Brisbane, where you will see vehicle flows from different origins and different destinations. In this case, it's focused mainly to Brisbane, but in there could be a city which can go to different locations. And when you have such vast of different ODs and different travel patterns, there is a concept called demand responsive traffic control, which try to control traffic networks based on the demand you get along road links and along the network. What it focuses is to optimize signal times and produce green waves or prioritize vehicle modes and so on. And there are so many examples that where these type of demand based traffic control being happening, and SCATS is the one of very close to us in Australia and New Zealand, because we have many intersections that operate based on the demand, and which could be corridor level, or which could be just intersection level, or which at region level operations. And in addition, there are some others as well, schools, OPACs, and roads, which I'm not going into detail today. So the target today is, in this piece of work, we want to regulate traffic flows at region level. So what it does is, in the earlier picture, you saw that it looks into all of them. Instead, now we identify certain regions in the network and control them based on the demand in that control network. For example, the middle region here has more number of vehicles, so it has high demand for the utilization, and we control that the vehicle accumulation in this region more carefully rather than other regions. So let's look at how we do that. So the concept or main process is, we identify a region and we try to identify the traffic controllers along the perimeter of this network. So there could be several traffic controls or traffic lights or intersections along this perimeter, and we try to control them such that vehicle flows from one region to another region is maintained at the optimum level. So thereby, so the vehicle flows, or the vehicle flows shown in this red arrow, are known as transfer flows, because they transfer from one region to another region, so that our signal times along these region boundaries, such that vehicle accumulations in most important region are protected, so that the high congested region will not go for gridlock conditions or so on. There are so many control algorithms available for this, such as network density, controlling the network density, controlling the network flow, and trying to control the boundary or transfer flows. Today's presentation is mainly focusing on boundary transfer flows, and we'll go into detail now. So there are existing or boundary control strategies or perimeter control strategies, we call them, because we control the perimeter of that region, which read some information such as region to region flows are perfectly known. So that means before we execute the control action, we assume that we know how many vehicles will be moving from one region to another region. That is not the exact scenario in the current context. And in addition, the literature assumes that vehicles share trip information such as their path, or route or final destination and their current location. So that most of the available literature assumes that vehicles are equipped with GPS detectors or some form of that, which can get this data. And then traffic data, including trajectory data, could be obtained in real time with high frequencies. Another assumption which we have in current existing uh, uh, control methods or existing algorithms. But however, this data is not that available, or it's not very practical to assume these that we have all this information, because one, the data may not be available at that high resolution. The other one is data, it could be very complex to control in real time type of data coming in and trying to process them together. So what we do in this research is to develop a method which only use loop detector data and only use real-time observations, or means, which means real-time observations mean every 2 seconds observations. And thereby we propose a network accumulation based macroscopic fundamental diagram model, which I will go into details shortly. And we develop a demand and route choice and traffic state estimation method in the real time, which is given by a moving horizon estimator, an estimator. And then we develop a controller, which is a model predictive controller, try to control the traffic lights along the boundary. And this is done in a repetitive manner so that we keep this control online or control real time. So I mentioned something about a macroscopic fundamental diagram earlier. So what does the macroscopic fundamental diagram? It means in fundamentals of traffic theory, we call a fundamental diagram which try to find the relationship between net flow and the density. But the same thing could be expanded to a network level where we try to understand the network flow versus network density. And when you do that, it has happened, the literature have found that any network that is well defined can have a network diagram like as shown here in these figures. And it could be scattered, but there would be some shape and form which we can define a mathematical relation between network level flows and density. In this study, we developed the controller based on the macroscopic fundamental diagram which I just explained. So here we define a region and it has an average network density and average network flow. So it has a, when you measure these, you can define a nice function. Right, so then let's go to the methodology, what happens in the traffic model. So when you have several regions and you have a fundamental diagram or mathematical relation to define network flow and network density, the traffic flow or network flow in between these regions is similar to uh, three reservoirs or reservoir system, where water, instead of water moving from one reservoir to another reservoir, here traffic flows from one region to another region. And then we can find the regions more details, such as uh, vehicle flows, and the rate of flow could be defined based on the continuity equation similar to water flow, but inflows and outways by using inflows and outflows. And then there are a few other parameters that we use, such as average trip length and route choice. So the water does not, or reservoir is not something that complex, but in uh, vehicle flows, we need to understand what is the route these vehicles going to take. So that's, and when you have such data being developed, what we try to define is a traffic dynamic without incorporating the destination of the destination region, which means we don't care about the vehicle goes, where the vehicle goes as the final destination. we only care about what is the previous region, what would be the next region. So that's the uh, information that we're going to have, and that is something which we can extract from the detector data or based on the route choices available from historical data. And based on that, we define the accumulation of a region given by this equation, which I'm not going into detail. What it simply does is extending the continuity equation to a region level traffic dynamics. And then this is the estimation part here, where we try to estimate the um, traffic dynamics or traffic. What we try to estimate is uh, we try to estimate the demand and route choice as a combined approach, where we develop an optimization problem where we say we can observe the outflows, and based on the MFD we can get the estimate for the outflows. And what we try to do in this process is to minimize the difference between estimated values and actual value. Again, it's similar to any minimization problem, but in addition to that estimation problem, we have some constraints defined by the macroscopic fundamental diagram, which is the network level traffic information, and then the region level accumulation levels, which gives us the regional traffic information. And then we try to provide some limits to the demand based on the prehistorical information we have. And then we define regional route choice as well, and we bound that regional route choice to certain boundaries. Again, that is coming from historical information, which is not which is a static constraint. And then uh, when you run this optimization problem, you can estimate what's the outflow in the very next time period. And we use that to control the traffic network in the current time period, in the following time period. So what we do is the next is model predictive controller, which tries to control the traffic network based on the estimates we got from the previous method. And that's again a minimization problem which targets to minimize the total vehicle accumulation in the network. And it again, how do you do the minimization? So if you want to minimize the number of vehicles in a given region, you have to minimize the number of vehicles entering and maximize the number of vehicles exiting. So to do that, the main control input is the way what data we have in the traffic controllers. And given these now all the traffic controllers are connected, we define a universal controller called UK for the current time period, which say, okay, we try to reduce the vehicle flows in these traffic lights, or we increase the vehicle flows, or we ideally it will convert into the green time or red time that we allow in any of these tra- traffic lights. From that, so that's the simple uh, concept behind this method. And I have done some numerical simulation focusing on different demand scenarios where we try to understand the performance of this estimator and traffic controller in demand conditions, where you will have a observed demand, and then you will have a variation to the observed demand by 25% up to 25% underestimation or overestimation. So what we found in when you do this traffic control, region level traffic control, is that this is what we have with previous level, where your region goes to a nearly gridlock condition, and with varying demands conditions that I shown here, when you execute the controller, you can control the network much better. So and what we understand is when you have at least about 5% of information on the network, you can control the network in a more optimistic or more practical way, rather than you having all the information. So what the final understanding coming from this analysis is you don't necessarily need to have all the information you need to control the region. Instead, you can have some information taken from the taken from loop detectors and devise them mathematically, run an optimization, which is a simple optimization. And based on that simple optimization, you can control the traffic lights along the boundary such that more favorable, less congested conditions could be achieved. Right, and then again, this is results about the demand estimation. So given that we change the estimate demand up from negative or underestimated by 25% to overestimation of 25%, although you have that by given with the information we have, what the results say is we can reach to a adequate estimate to control the network. We will not be able to estimate the network to the 100% level, but the estimation results that we get is adequate enough to control the network and maintain less congested conditions in the traffic network. So that the combined approach of this estimation and control is not necessarily to achieve perfect estimation or perfect control, but to a hybrid point where we can execute and control algorithm with practically with the available information. So let me summarize what we did on this research. We developed a control hybrid estimation and control mechanism where we try to operate a large scale traffic control mechanism with less without high resolution data from traffic networks such as trajectory data or physical GPS points. We only use loop detector data taken from the network, and to do that we develop a moving horizon estimator which is a nonlinear estimation method, and then we develop a model predictive controller to control the traffic networks. Out of available, while there are some issues in the available methods, the proposed method is a combined framework which can estimate traffic flows and route choices, and it proposed a 4-region trip-based model as well, and then it proposed an accumulation model that is simpler to control and simpler to estimate. So with that, without further ado, I will and if you have any questions or anything, happy to answer or have them.
Thanks, Akita. We'll get to the questions in the end. I'll pass on the mic to Isaac.
Thanks for that. I'll just share my screen. So hopefully that's showing. So my name is Isaac. I'm doing a presentation on a project titled Access-Based Cost-Benefit Analysis. This was a project undertaken as part of my honours thesis year, last year. And we're fortunate enough to get it published earlier this year in the Journal of Transport Geography. So we really wanted to look at the appraisal of transport mega projects. So to be clear, the mega project is generally defined as an extremely large scale investment worth over $1 billion. There's ample research that certifies consistent and significant historical trends in forecast inaccuracies for these mega projects. So popular study undertaken by Bent Fluberg looked at 210 projects across multiple nations. They found that 90% of rail projects had overestimated passenger forecasts, of which the overestimation amount was around 106%. So fairly significant. Here are some charts from that paper. On the left, you can see a distribution of forecast inaccuracy. On the right is the reported reason for this inaccuracy. I think this is rather interesting, and it definitely highlights that inaccuracy sort of stems from the travel demand side during business case development. Of course, a quick Google search shows this is definitely a local issue for Sydney, with some popular news headlines that have been reported for Rozelle, for instance, and various metro projects. So these mega projects are typically appraised using a process called cost-benefit analysis. So this research focuses largely on the benefit side of this. The benefits or welfare for transport projects are typically the summation of transport benefits, land use benefits, and wider economic benefits. Transport benefits are generally the most profound and adopt a consumer surplus approach, aligned with typical microeconomics. And these are calculated using a rule of a half approach. An example demand curve shown on screen, taken from ATAP guidance. So importantly, these rely on value of travel time savings. So value of travel time accounts for around 60 to 80% of quantified benefits in this process. And I've listed some common criticisms associated with this. It encourages faster modes, sprawl developments, benefits users with higher value of travel time savings. It has a strong dependence on complex travel demand models and is subject to optimism bias. So we looked at using accessibility as an alternative to conventional CBA. So accessibility is a well-known planning concept. It's typically described using the Hansen equation and cumulative opportunity metric. So that equation is shown on the screen. This is simply saying that accessibility at a given location is the sum of opportunities, say access to employment, that can be reached within a given threshold. In this instance, such as 30 minutes. This combines measures of mobility and land use. It can measure the value that a transport system offers. It can be tested in base and project scenarios. And importantly is this last point, where it reflects the reality where specific trips that future travelers make are actually unknown. So here's some access plots. Here's 30-minute access for Greater Sydney by transit within the AM peak. And this increases for 60 minutes. As you can see, access sort of clusters around heavy rail corridors and towards the city centre, which we would expect. So we've got this idea of access. How do we monetize it? How do we convert it to a dollar figure so it can be used in cost-benefit analysis? Well, firstly, we know that significant increases in land value accrue from transport investments, and a positive correlation between access to job opportunities and land value is well established. This can be measured using hedonic regression. So a simple log-log model is shown on screen, showing the positive correlation between access and land value. So this is somewhat discussed in literature. The current studies generally fall short of cost-benefit analysis implementation, and to be fair, that's not really their intention. And also inconsistent measures of access. So it's often measured as a proximity to a railway station, for instance, not so much the amount of opportunities that you would have access to. So following a literature review, we defined these thesis objectives. The first one is to replace a typical travel cost or direct transport benefits in conventional CBA to avoid the same issues with it, but importantly to avoid double counting. The next is to monetize access. So access is a non-market good. We need to develop a sort of a process to convert that to a dollar figure. And the last objective is to offer a reproducible methodology. So we wanted to test our theory on the Southwest Metrolink. So that's that line at the bottom of the screen shown in blue. This is a metro technology that links Glenfield with the Aerotropolis and links in with the Metro Western Sydney Airport, that north-south line in green. New stations are shown as the blue dots. So the method involved 3 major steps. First was to develop a hedonic price model of Sydney. The next was to compare before and after project scenarios for the Southwest Metrolink. And the last was to perform cost-benefit analysis. So the hedonic, some results of the hedonic price model shown on screen. You can see the correlations matrix between access, land value, and other inputted variables. We ran linear and log-log OLS models. So the sort of the top halves of the tables are shown here. I think the interesting results here are highlighted. These are elasticities. So these are essentially saying per 1% increase in accessibility, that's, property has access to, we see about a 0.2% increase in land value per meter square. So these results become valuable for the cost-benefit analysis process. Next was to create the access model for the Southwest Metrolink. This screen's showing essentially the different scenarios that we tested. Notably, we tested base and transit-oriented development land use scenarios for both 2031 and 2061. Here are some of those results. This is a 2061 scenario showing access gains and losses. On the left is the base land use scenario. So that's essentially uniformly distributed land use per transport for New South Wales travel zone projections. On the right is TOD land use. So that's where you get intensified land use about these new stations. And as you can see, there are some access losses resulting from removal or cropping of the heavy rail line between Leppington and Glenfield. So there are some losses associated with the base scenario. However, the TOD scenarios offset those losses through more intensified land use. Next was to perform cost-benefit analysis. So combining steps 1 and 2, we essentially found the land value appreciation sort of near the project corridor that we would expect from the elasticities generated from the OLS model. We ran this over 6 different scenarios, including both our linear and semi-log models, and as well for different access thresholds. There was a bit of a distribution of these results, so we did take the mean, sort of following a crude ensemble model type approach. We worked out the mean or the average expected appreciation near the project corridor, and these figures are highlighted. We've got the 2031 benefits offered by the project are around 1.8 billion versus the 2061, which is around 3 billion. Interestingly, the 2061 base land use scenario is lower than the 2031 benefits. And that's sort of demonstrating that access follows the law of diminishing marginal utility. As the peripheral network develops, access becomes more abundant and less value is actually offered by the project. That's offset in the TOD scenario. Next, we performed preliminary costing for the Southwest Metrolink. This was done looking at existing costing for metro projects around Sydney and working out an expected distribution of costs. As you can see, the distribution is pretty wide, between $2 to $5 billion. Then we looked at our benefit cost ratios and plotted them. We can see the project only has a BCR above 1 for sort of very strict scenarios when BCR is 1 or BCR is 2, assuming the annuity access discount rate is low. So this can be thought of as a social value in conventional cost-benefit analysis. It's what value do current residents assign to future benefits or future access gains. So we can see that, there's only a very strict circumstances where the project would have a BCR greater than 1. So here's a summary of the results. Our hedonic regression shows around a 0.2% increase in land value per square meter per 1% increase in job accessibility. That's a linear rate for the linear hedonic price model. Project benefits are around 1.8 billion in 2031 and between 1.5 and 3 billion in 2061. Strategic costing reveals a range between 2 to 5 billion. So we conclude that our BCR is greater than 1 in terms of land use benefits. If TOD, if there's TOD development, project costs are minimal, and future access is valued highly in the present. So the implications for this research, well, firstly, it's an alternative method of cost-benefit analysis. It doesn't have strong dependence on value of travel time savings and the corresponding complex travel demand models associated with that. Has direct application in value capture strategy. After all, we are looking at property premiums that would be generated by the project. Tractability, it's easily reproducible. It relies on minimal computational power. And the idea of that is to improve its reproducibility and transparency in the business case. And importantly, it establishes avenues for further research. So looking at how it interacts with land use transport integration modeling, wider economic benefits, alternate methods of hedonic regression, such as spatial models and different types of panel models. So thanks for listening, and any questions?
Thanks, Isaac. That was great to know about cost-benefit analysis. I work in the rail sector as well. So next is Max.
Good afternoon, everyone. My name is Max McCardle. I'm an active transport lead at Safe Systems Solutions, and I'm actually in the middle of some site inspections out in Western Victoria, and I've just popped into the Stawell Public Library to run this presentation. So I want to thank the library staff for giving me an office here. And I'd also like to acknowledge the Jabwaran people, who are the traditional custodians on the land that I am on today. The presentation I've got to go through is my experiences at the ITE annual meeting in Portland, Oregon in 2023, and hopefully get others interested in joining ITE and also the wonderful opportunities that come with it. So I'd like to acknowledge ITE and Austraffic. I'd like to thank them for providing this opportunity for myself to be able to go over to Portland. First time I've ever been. So it was pretty exciting. And it was a full-on week. There was a packed schedule with lots of different technical learnings pertinent to my career. All of the plenary discussions and workshops and things like that were held at the Oregon Convention Center, which was on Martin Luther King Boulevard. That's a statue of Martin Luther King. And we were lucky enough to have some incredibly warm weather, nearly 40 degrees every day. And I kept being told how unseasonably warm that was. So that was a nice thing to arrive to. I am an early riser, so this is before anything got started, but when there were discussions being held, every single seat was filled and there was people standing, because it's just such a big event, these annual meetings, and the speakers were very prominent in their field. So it's lots of good discussions being held. There was a myriad of exhibitors as well, plenty of opportunities over lunch and morning tea breaks and things like that to head around and have a chat to different providers, and not just because they're trying to sell their products, but they were very, very interested as to why an Australian was there and where I got that accent from. And they were incredibly friendly, and that then led on to networking events and other social activities outside of the conference. So it's really, really exciting to have that opportunity to engage with professionals from another jurisdiction. One of my favorite workshops was the Safe Systems Solutions in Highway Safety Improvement Projects. This was actually on the Sunday before the conference. I was really excited for this because I work for the company Safe Systems Solutions. So I knew it'd be incredibly relevant. And indeed, it was basically a workshop discussing what we would refer to as safe system assessments. US are interested in rolling out something similar across their jurisdictions. They're at the infancy stage of those things, and they actually reference the Victorian Safe System Assessment Framework document, which I'm incredibly familiar with. So it's very pertinent to, I guess, the work that I do to be involved in that workshop, and felt like I could add some real value in and being part of that conversation. Another highlight for me was witnessing the ITE Collegiate Traffic Bowl. This is where different colleges across the US, students from different colleges, they come together and they get quizzed on how good their traffic engineering knowledge is. There's some amazingly detailed questions that people just seem to know at the top of their head. And it's like emceed, and there's party streamers and balloons, and it's a real kind of party atmosphere. It's a lot of fun, and there is an eventual winner. There's like knockout stages and things like that. The winner gets home with a trophy and a bit of money and things like that. But super competitive, and a lot of fun to witness the traffic bowl. But one of my main highlights was visiting the Blumenau Bridge. So this was actually a technical walking tour. It was one of those 40-degree days that we did do this tour, so it was incredibly hot, but it was certainly incredibly informative as well. The Blumenau Bridge was pioneered by this gentleman on the left. His name is Earl Blumenau. He's a congressman. You'll notice that he's wearing a bow tie that will become relevant later on. He's always been passionate about active transport in Portland, and he's been advocating for a pedestrian and cycling link into the downtown area for many years. And he's kind of championed this bridge. So this bridge is actually not open to any motor vehicle traffic. It's only for people walking or riding their bike. No vehicle access whatsoever. However, they had the foresight of building the bridge to be able to withstand high-level magnitude earthquakes, because where Oregon and Portland is, it's actually adjacent to the Cascadia subduction zone. And they haven't had a significant earthquake since the 1700s. By significant, I mean greater than 9 magnitude. In the next 50 years, though, they are expecting something of that magnitude to occur. And when that does happen, not only will it be the shaking of the ground, but it will be also a tsunami occurring. Existing bridges that exist in Portland are expected to fail. So all of these bridges kind of connecting to the downtown area are not expected to be able to withstand that impact, whereas the Blumenau Bridge has been deliberately built to be able to withstand those forces. And if it is to occur, it's actually wide enough to have 2 lanes of traffic. So that would actually get opened up to vehicles. So emergency services can attend, any of the events that have occurred in the downtown. So it's very good forward thinking. Here's what it looks like out on the deck. So you can see it is quite a wide bridge. So certainly for pedestrians and for people riding their bikes, it's incredibly wide. Fun little fact that I found out about this little, draw it quite in the right spot, this little gap in the pedestrian fencing there, that was deliberately installed. It's just like a little opening. It's so people can put their hand through it with their camera or their phone and take a nice photo of the length of the bridge. So it's purely there for that purpose. And I've been told anecdotally that there are a lot of phones at the bottom of the bridge because people frequently drop their phone. So Earl Blumenau, he's got this lovely plaque out of recognition for his contribution for kind of leading this development of the bridge. But I also really liked a nice little touch, the bicycle symbols adjacent the bridge. They've included his little signature bow tie because he's famous for wearing the bow tie, and so those stencil pavement markings, they've included a bow tie. Very lovely little reminder of, I guess, the successful advocate for this project. I've gone through it quite quickly, but I probably could have taken more time. I really enjoyed not just the conference aspect or the annual meeting side of things, but tacked on a few extra days and did some cycling around Portland. Portland for me has always been the #1 destination in the US. I've always wanted to go to Portland because of their cycling prowess. They're known as the best city in the US for cycling connectivity. So I've always wanted to go and ride my bike, and this opportunity gave me that experience. So I did hire a bicycle, and I got to see a lot of the trails, a lot of the cycling improvement and networks that they've achieved over the years. So Portland has been, since the 90s, really trying to advocate for better cycling safety and networks across their jurisdiction, and it is very, very much a cycling city now. So it was wonderful for me to be able to go out and to ride through those networks from both a professional development experience and also just like as a bucket list thing. So it was a wonderful opportunity for me. I've included my LinkedIn profile if anyone wants to connect via LinkedIn. I'm more than happy to have a chat about all things cycling or anything regarding active transport.
Thanks, Max. That was really interesting to know how your experience in this trip. Thanks, Isaac, as well. We don't have some active questions in the Q&A. I got a couple from the back of my mind. Max, what was what was in your experience? What was the most benefit that you got from this whole trip to Portland?
I definitely think it was the networking. So it was incredibly easy to go up to complete strangers and introduce yourself and just have a conversation and hear about how others are working within the transport industry and learning from their experiences. It was an incredibly social and friendly environment that just led to that ease of conversation and things like that. There are also a myriad of social activities, after the conference, dinners and karaoke nights and things like that. So plenty of opportunities for you to meet others in the industry and from a completely different jurisdiction where they are much, much more litigious, and then much, much more you need to follow every single standard and guideline, otherwise you'll be up for suing. So it's really, really curious how that side of the world works, and it kind of opened my eyes about the US practices.
Yes, they do really care for due diligence in all their activities, especially the ones which are federal funded. They follow a particular process in systems engineering and go throughout that. Another thing, just to follow up on that was, are you still in touch with any of the people that you met over there, so that the networking, does it continue even after you've been back over here?
It certainly does.
Okay.
Whilst I was there, I met some of the cycling kind of gurus from the city of Portland, the Bureau of Transport. And yeah, I just wanted to introduce myself. So we had kind of separate coffee sessions where I met them at their offices and things like that. And just wanted to hear about their plans for the future and how they've helped to develop some of their networks to date and things like that. And yes, we continue to liaise, and we've kind of built that connection, which is wonderful.
That's great to know. That's the most important part of it, like personal connections and international knowledge sharing. And Isaac, I had still I can't see any Q&A in the chat box. So I had a question for you. Why did you choose rail projects only in your scope? Like, I mean, was there any particular aspect to choose that because it's like more complex or something?
Well, yeah, I guess metro is sort of the hot topic in Sydney at the moment.
Okay.
So being able to apply the method to a potentially new metro project, which may eventually come in, I think was appealing. But the method isn't just rail specific.
Yes.
It can be applied to auto modes or even walking and cycling, as accessibility is a fairly inclusive metric.
Yes.
So you can gauge accessibility through other modes and possibly even combine it in a hedonic model. You can look at how, you know, what accessibility gains do you get from different modes, and look at options for combining that. So yeah, not a specific reason we chose rail, more because it's just
Yeah.
sort of a hot topic in Sydney at the moment.
I agree. I mean, in terms of costs as well.
Yes, yeah, a
cost
lot of
overruns.
investment in that space. Yeah,
That's one thing. I still can't find any further question. Pardon if you are hearing a baby. I'm babysitting my own little son. Uh, so with that, I think I'll just close the session. Thank you, Max, and thanks, Isaac. Before I end, I do have a couple of things to share. I'll just do that. Thanks. So we do have an upcoming webinar, a hot topic on 13th of November, the new parking standards and what's changing in the new revised standard. We have Oleg from TEF Consulting and Wes Edwards from Arrive Limited in New Zealand. And this is a hot topic basically because of we all want to know what's changing in these new parking standards and guidelines. So tune in, sign up for this or subscribe to us so you'll receive an email from us to log in. The next upcoming event is the President's Dinner. And we've got Dean who's the CEO of HMI Technologies and International Ambassador of the ITS Australia. And it's on 19th of November at Q Golf Club. So please join in and register for this. It's going to be a great session. It's an annual event, which ITE ANZ keeps rolling up annually. And as for today, thank you to our speakers, Sakita, Max, and Isaac. It was great listening to all those presentations. Thanks, Max, for sharing your experience, so that in future people would know if they apply what can they expect in US. And thanks, Isaac. It's good to know, and good luck with your PhD. Thank you, everyone who's joined on this call, and have a nice afternoon. Bye.
Thank you very much. Bye.
thanks everyone.